Okay, and we are now recording. This is the May 21st KEP review for the Object Storage API. I'm going to go ahead and share screen. And let's see if I can find my... Okay, can everyone see that? Should be a slide deck.
Yep.
Okay,
yeah,
cool. So, given last week's discussion around the need for a credentialing API and some sort of mechanism, at least a basic way of handling that, we spent some time kind of brainstorming on that. Threw together a slide deck yesterday to kind of illustrate the different models that we think are viable. There are certainly more out there that we haven't considered yet, but this is kind of where our head's at. So I think the approach we're trying to take is kind of a minimalistic sort of change to the API, since we're not trying to write like a full-fledged IAM operator, but we're still trying to enable credential minting specific to buckets. There's a bit of there's at least some amount of like IAM ops that have to happen. I'm not going to get into those very much in the slide deck, but hopefully the conversation will lead to that. So the first one I call discrete minting. It is essentially a standalone API that interacts with Cozy. It could be part of the Cozy interface. And sorry, I'll put these slides up in the Google group here in a bit. While the graph here looks pretty complicated, just note that the right-hand side APIs, the original bucket proposal APIs, are unchanged. They are renamed. Bucket request replaces bucket. Bucket replaces bucket content. I don't know what the names will be next week, but that's what we're going to call them right now. On the left-hand side, so the idea behind this is a user has to request credentials through an API, get those credentials back, and then specify those credentials when they request a bucket. The mechanism used to pass them to the driver is that they will have to be created. This is just a factor of the automation anyway. The driver will have to create the secret with the credentials in its own namespace. A central controller will have to clone that secret to a user's namespace, and this is part of the minimally privileged and driver philosophy. Whoops. Okay. So a user would create a bucket credential request that would create a cluster scoped bucket credential, which is essentially just a dereferencing tool. It has to exist because the driver can't see into user namespaces. So it has to look somewhere. Cluster scoped objects are the method by which we communicate with the driver. So that to me just makes sense. Once it detects a new bucket credential, it creates a new set of IAM credentials, writes those into its own namespace, updates the bucket credential. Central controller would clone that back into the user namespace. Now the user's ready to provision a bucket or buckets. They create their bucket request with reference to the secret. A bucket is created in the cluster scope. The driver, not illustrated here, will have to dereference this secret, or rather the secret within its own namespace, through some manner. So this could be through an annotation on the cloned secret, or a direct reference, say between the bucket request and the bucket credential request. But some way it has to know that this is the secret that should be used to create the bucket. Creates the bucket, binds that set of credentials to the bucket. How that's done is mostly on the driver's side, so we don't have a way of controlling that, but we can prescribe things like, please make this the owner, or please bind it with this set of credentials, and leave
John,
it up to the
I'm
driver.
sorry.
Yeah, go ahead.
Can I interrupt you just for a second? Because
Sure, yeah.
I was following and then I got lost. So I tend to think of this as there are two things that have to be created in the cloud service. Mm-hmm. There is two things that may have to be created, right? So one of them is a principal, a user, right? You have a bucket, you have a user, and then you have a set of access for that user to that bucket. And theoretically, whether it's a user plus access or whether it's a user and access together could be abstracted to some extent. But I guess what I don't understand is the implication that creating the bucket involves the same set of credentials as would be out at the pod, because I think in general what you would want is an account that your provisioner uses and has access to that is probably a somewhat unconstrained, can, for example, create, delete bucket and do other things.
Yes. So yeah,
Relative to the
that is not shown here at all. But yeah, absolutely. The provisioner should have, and so I've kind of excluded that because the graph gets very complex if I start to show.
Okay, so then
sets.
those credentials are not used to create the bucket.
Yeah.
That's what you
Right.
said, but I don't think that's what you meant.
I would imagine that there's
yeah, sorry,
like yeah, I would imagine that the driver is somewhere sitting here, right? And then that's the one holding those credentials.
Yes.
And then,
yeah, and then it has a higher privilege secret, either in its own namespace or say referenced through the bucket class or some other mode that we'll figure out later, but maybe in a fashion similar to how CSI allows for templating of provisioner bucket names, etc. But none of that is shown here for simplicity. So I'm trying to just show why I guess the acting APIs here. So yeah, please assume for all these that the driver is credentialed, it exists in the driver namespace, and that's all kind of in the background.
So I like the direction that this is going. One piece of feedback right off the bat is the lack of a bucket credential class. Seems to imply that bucket credential request will need to contain cloud service specific things inside the bucket credential request, which would make it not portable.
Yeah, no, that's something we had talked about yesterday, in fact, and okay. I had slapped this graph together or redesigned it today, and I actually omitted some of that, and I think they all omit it to some degree. There's our thought on that was that, well, the bucket credential request should probably either reference a new API, like you said, a credential class, or the bucket class. I think a credential class is probably the better way to go, given that it would probably specify credential specific parameters and would also name a provisioner. So that, yeah, sorry, this is all a bit hastily put together, which is on me, but.
So let me add another little twist to this, and I sent notes out right before the meeting, which probably didn't help since nobody could get a chance.
Sorry, I scanned through about half of them.
Yeah,
yeah.
One of the things that Tim brought up in an earlier discussion, and I referenced it more explicitly here. The problem with passing user credentials in a secret, is that you end up having to have a set of credentials that are outside of your credentialing system stored out there. And so it's generally not a great mechanism from a security perspective. It has historically been the only mechanism that we have in Kubernetes, but I have to believe that a lot of Kubernetes platforms are going to be moving to something like workload identity, right? Which basically maps a Kubernetes service account to an IAM principal in the cloud service, so that the minting problem here becomes just the access credentials. So there's still a provisioning problem. You still have to provision access to a particular bucket, but there's no need necessarily to communicate those credentials back to the workload. Does that make sense?
Yeah, I'm a little familiar with that. I've read about the workload identity. AWS has a similar solution. Azure, I think, has something in the same vein. Where
and so what I would ask is that we figure out how in this model we could accommodate that, but also probably still have that fallback to be able to do, passing it via secret. So it's just sort of a question of, how would you express the two different problems of minting a principal and or minting just access for an existing principal?
It's funny you mentioned that. I talked to Tim this week about this design, and he had exactly that feedback. He said, make sure to allow for both secret and secretless access, which is exactly what you're saying. This design is for secrets, but also allow for workload identity, which you don't have to provide a secret. The identity of the pod is passed through, and either something within Kubernetes converts it to, maps it before passing it to the cloud service, or the cloud service natively understands the Kubernetes identity. Regardless, allow for both modes.
Right. So in my mind, the simplest way to make that happen, if y'all can see me kind of messing around here, is through the class, right? So if you have a class that's either A or, let me just delete this annoying line here. If you have a class that is for supporting the workload identity style of credential creation, or rather IAM management, then that's what that class would represent. This would be a like IAM class or something of that nature.
Yeah, just the terminology. In this case, what we're really configuring is not credentials then. What we're configuring is access.
Right.
Right. I have a question here. Oh. You want to finish that thought, Andrew? I have a question, but I can wait for you to finish that part.
Yeah, I was just going to say, if you think of this again as potentially a two-part provisioning problem and then a one-part communication problem. The two-part provisioning is whether you provision a principal and or you provision just the access. The provisioning of the principal, we're now saying, is optional because you might want to do that through workload identity or the equivalent. And so, but the thing that's always there, theoretically, is provisioning the access. And so you could either bring provisioning of the principal itself out of bound and make it basically a three-part problem. You provision a bucket, you provision principal, and you provision access. Or you can combine the principal and access provisioning together with lots of optionality in the class. But we just did that with Bucket and decided to pull the two out. And I suspect that wasn't just because of the security implications. It was because we were conjoining abstractions. So I'm wondering if we might want to treat some sort of principal identification as independent of the access configuration, if that makes any sense at all. I tried to explain it in the notes also.
Right. Yeah, and I get your point too. So the point here is that, like you said, it's essentially a three-part problem. You have an identity, you have a storage endpoint, you have the binding that takes place that prescribes, your access. So a second kind of complication of this is that binding can be written to the bucket or written to the IAM role, right? So it also exists in both sections. Now, how we represent both, I don't really know yet. My initial thoughts is that policy has to take place either at the, well, I guess I was thinking it takes place probably at the point of bucket, either binding or like access permission. So when the bucket request is created, policy has to be written in there somewhere. And another complication of that is that, should administrators be the sole proprietors for defining the access, or should users be able to request a set of access policies, right? Like I would like write access to that bucket, and I would like read access to that bucket.
So it strikes me there's two different problems here, and I don't know if you're trying to put them in the same abstraction, but one problem is, what buckets am I allowed to know about? The next problem is, what buckets can my application access? So application access to a bucket requires something in the cloud service to enable. But whether or not I can know about a bucket is entirely a Kubernetes level problem, right? So this would be the question of, am I allowed to put a bucket request against a bucket? Is the Kubernetes level problem. But the problem of whether or not my particular application can access that bucket is the problem of this bucket access, the left-hand side.
Right.
So I don't know,
yeah.
which of those problems were you describing?
So I'm still speaking only to the cloud service layer. And
right.
in the
So
cloud,
can we not abstract that? I mean, so if we build this layered architecture, which is sort of implied by what you've got here, that no matter what we do, it has to be instantiated in the cloud service, right? Whether that means it's instantiated in an IAM role that's independent of the bucket but refers to the bucket, or whether it's some kind of property in the bucket itself that refers to the, you know, either way, that is an abstraction that can be black box, right?
right. In terms of having a, yeah, well, yeah, I see what you mean. So regardless of how the driver connects the identity to the bucket, that's not really our concern, so long as it adheres to whatever policies we ask it to provide. Is that,
right.
Am I kind of on the right track there?
That was the point that I was trying to make. And in a different part of this problem, I do think we have whole fundamental questions about reuse of bucket and bucket request and multiple binding, single binding. We started to talk a little bit about that last week. I just wanted to make sure you weren't sneaking that in at this point when we were talking about access.
No. And yeah, that's another problem entirely, which that gets into like the you know, having a whitelist kind of structure within the cluster scoped object of the bucket, prescribing which namespaces can connect to it, and then Cozy would have to, you know, be very diligent about checking that list.
Yeah,
but yeah, no, I'm not talking about that yet.
The cleanup problem, which is,
yeah.
you know, are you going to keep references for all of your things? Are you going to block deletion of the bucket while it's still being referenced by bucket requests? I mean, you know, all of that.
Right. And I think for now, and my sense is that you probably agree with me, is that we should leave that for a later conversation about, that's more about an automation implementation at that point.
Yep.
Okay, cool. Yeah.
I have a question, John, because I also like the direction where this is going. My first question would be, it seems to me that the bucket request itself implies a lot of things because it requires the class. So the class will determine what type of credentials will be provided. So why can't we start with the bucket request? Because the bucket credentials coming first seem to me that like a two-step might be too much, because when you're requesting the bucket, you already know you want a GCS style of bucket, and you're going to get certain type of credentials. You may actually be getting a file as well mounted. And so I think that the bucket request will be enough to imply both what bucket I want along with the class, and then the credentials that I'm expecting. And then this object makes a lot of sense to me because it kind of holds what was already provided to you. But I feel like if you have the driver here on your diagram, this bucket credential request could be stored somehow by the driver or referenced by the driver. So to know what your application was granted when it created the bucket request the first time. So that's my question: why bucket request cannot just be the whole enchilada?
So can I address part of that, which is that I don't think merely knowing the particular, say, data path API gives you adequate information about the way you're going to handle credentials. Because, for example, there's a whole bunch of S3 compliant guys that might describe credentials in the same way, but the way they're provisioned and everything else might be very different. But also, even when you've got the same thing, like GCS, for example, you might in some cases support workload identity, in other cases support secret. So there really is a whole class of problems that are just about how you represent credentials and things like that, that are kind of independent of whether or not the bucket gets provisioned. And then the other thing, which is what led to the split in the first place, which is that you know, we want to keep bucket provisioning about bucket provisioning, not about credentials. And you can provision a bucket before putting any kind of, I mean, there's a strict ordering there. You can completely provision it without adding access credentials and then apply access credentials after the fact. The reverse is not always true.
That's interesting. On this diagram, I have a question for John, or maybe you, Andrew, can answer. I don't really, could you please clarify where exactly we grant access to credentials? Because now from this diagram, I don't really see where exactly that happens, at which step we do grant access.
When we grant access to credentials, as in
Yes.
when do we, when are they minted?
Exactly. So I do see that, like, I do see when we provision our like IAM credentials, I see where we provision a bucket, but I don't see where we actually grant these new IAM credentials access to the bucket. If you could clarify that.
I think they're doing it as a single step.
Right. So if you can see right here, yes. So this right here, this connection, when the bucket request is made, it has to reference a secret. Some back referencing is going to have to take place because the driver cannot, you know, the driver's here and it can't read the secret in the application namespace. So we're going to have to add either through annotation.
But the secret is not known, right?
Why does the bucket, I'm sorry. I don't understand why the bucket request has to reference the secret. Why does it even have to know about, has to know such a thing exists?
So here, well, I guess here's the end goal, right? The credentials have to get, the pod has to have access, credentialed access to that bucket in some fashion. So if the bucket is created in this model, the binding and the creation happen in the same operation is the intent here. So I send my request, I say, hey, please give me a bucket, bind these credentials to it.
But why do they have to be together? Why can't you strictly layer it so that bucket provisioning can be a completely independent step of bucket credentialment?
Because
what allows for is sharing of buckets.
Because you want to be able, I get what you're saying, Andrew, but for brownfield, I assume we would need the credentials in order to bind, for lack of a better word, to that bucket.
So I'm sorry, let me be clear about what I'm suggesting. I'm suggesting that you have a flow that results in actual provisioning of a bucket in the cloud service.
Yes.
That's a flow you only have to execute once per actual bucket.
Correct.
Right?
Yep.
So then you need to support a flow where you reference an existing bucket, and that's where all these sort of namespace level access control kind of things come in. But at the result of that, all you get is a handle. You get a bucket endpoint. You know where a bucket is. You can't actually get your application to access it yet because it hasn't been granted access. But to do that, then you go over and do an access request and refer to the bucket in the access request. An access request is real simple.
So I think I even diagrammed this out.
I agree completely with that statement, and that would fulfill the brownfield use case as well, right? If either way it exists, then we grant access. I think the trickiness came around the one-to-many access as well if it's not a list, which I understand the complication around maintaining that. But
I'm slow here. I missed the, why is the back reference from bucket request to secret not necessary?
Because you don't need secrets at all for bucket provisioning. You only need the provisioner's secret. The pod's secret is irrelevant because that's about accessing it. It's strictly layered. One depends on the other, but not vice versa, is my argument.
Right, but if it's required for access, in order to consume that bucket request from the pod, you need to specify a secret, right?
No, I'm saying that mechanism is not about consuming the bucket request. It's about in other words, the pod one of the ways to look at this is that a pod only ever has to specify a bucket access request. That bucket access request might refer to an existing bucket or might ask for a bucket to be provisioned. Now, exactly how that works out, if that means you always have to have a local handle to the bucket, but that's the way that I was looking at it is that if you have sort of two separate provisioning systems, they have very different cardinalities. And so you don't want to combine them together.
Oh, that's an interesting thought. Okay.
Yeah, that's exactly my point. It looks like we are missing one more step here, is where we actually grant access to the credentials, to the service account, let's say.
Now, a question about that. So what that implies is that this bucket access has all the information that a pod would need to access that bucket. My initial thought was that this bucket access would only include kind of access credentials information, not necessarily information about where, how to connect with the bucket otherwise.
Yeah, I was actually imagining in this updated model that we would no longer try to tunnel all of this through a single communication path. So bucket information we could provide via config map, and then credential information, if required, which it wouldn't be for the workload identity case, you'd provide via sequence. But by keeping those two paths completely separate, they can be, mounted or whatever. I mean, that's a problem of the interface definition with the particular expectation of the application. But yeah, tunneling them through the same thing implies that you end up having two flows that have to update the same resource, which feels weird to me.
Interesting. Okay.
Yeah, I feel like, like having that single resource defining how the accessing the request and the credential request is going to happen simplifies a lot, right, of the discussion, because then the bucket credential request and the bucket request itself turns into just cozy behavior. It's no longer relevant to the developer or the administrator that's managing access to the bucket, right? He's only trying to satisfy what the pod is actually going to need in one single place, and then everything else is part of the automation.
The question is how bucket access can be reused when we're talking about brownfield bucket versus brownfield credential, right? So that they exist. What should you do? Should you refer to the bypass the bucket request and just refer to the bucket directly, and also bypass the request for credentials and refer directly to something else like a secret or even like a model of workload identity? Or what is the
my gut is that you
brownfield
would
case?
Requests probably in the application namespace for both, right? Because that represents the thing that can trigger population of the path down to the app and et cetera. And then once you did that approach, once you have a request for both, that request can then either be satisfied via a pre-provision, brownfieldy or driverless case, or it can be dynamic. Separating them allows you to separate the dynamic part. You can dynamically mint the bucket, but not dynamically mint the credentials. You can dynamically mint the credentials, but not the bucket.
No, I'm totally up for it, but what I don't follow is that the access should support two cases of referring to a bucket in some way, because if it wants to be deployed with bucket request, for example, then for the sake of simplicity, I would probably want to refer to the bucket request that I'm deploying, right? But if I'm deploying it without requesting for a new bucket, but actually, just referring to something that I expect to exist, how should I refer to it?
I think you should refer to it by name. So that's the case for brownfield buckets, and it's a great scenario because bucket access could standardize, right? If you're requesting a bucket which the system cannot provide you because it doesn't understand, let's say you're requesting a bucket called logs, but I mean, if you're with AWS, that bucket name is probably already taken. So that means we should make the pod unschedulable, so that administrator knows that he needs to come and look a way to satisfy this bucket access by creating a bucket object that can satisfy the bucket access request, right? So this will satisfy both. I mean, if you are configuring in a way that request for a bucket called logs can be provisioned, it will be provisioned, so a bucket object will be created and then you will be granted access. Or if you're in an environment that's working with a cloud provider, and then these requested names need to be mapped to actual backend buckets, this will actually be some extra work for the administrator to come and satisfy your bucket access somehow with the proper names for the buckets, right?
So I'm not sure if I'm completely understanding what you're suggesting. You're suggesting to keep provisioning, so to keep creating a bucket request, even if I want to reuse an existing bucket, and then the bucket access will always, so that every usage for that case would require 3 objects: bucket access, request, and credentials. Because these will be able to detect if I'm referring to something existing, or that the bucket access would sort of refer to the existing, the pre-existing entity. That's sort of 2 different models for bucket access.
I think bucket access, it's something that applications will ship along with their pod definitions anyway. But I think the bucket request will be created anyway for both greenfield and brownfields, because you need somehow to know which buckets are in use, right? And the only way you can know if actually anyone is using this bucket is by getting it. So even in that sense, maybe making a cluster scope, the bucket request will make sense. So you can see, just like volume claims, right? Volume claims, you can see which volume is being claimed by what pod on which namespace. So bucket request could actually end up becoming like a claim to a bucket, right? So
yeah, the problem is if we do a many-to-one, it's not clear how you manage that. That's the main question: is do you do the many-to-one with many requests linking to the same bucket, or do you have a sort of union, where you have an access request that can either refer to a bucket request or can refer to an existing underlying bucket, which is, but.
When you're saying many to one, you're asking many bucket requests to one bucket, or one bucket request requesting multiple buckets?
So the overall problem, right? The brownfield problem is there is one underlying cloud service bucket, right? Mm-hmm. And then we want to have multiple different pods access that. So first question is, how many different cluster scope buckets do we have for a particular underlying bucket? I think we've been converging on the idea that there would be a one-to-one there because lifecycle management is very difficult otherwise. So if there's one cluster scope bucket for each cloud service bucket, then you have the next tier up problem, which is how do you do the many-to-one from the pod to that? Mm-hmm. And this is the whole problem. We said we were going to defer, but I think it's a legit problem to figure out how you do that fan out. You can fan out by doing multiple cluster scope buckets that point to the same thing and punt on lifecycle management, or you have to implement an entire strategy for having multiple bindings to a bucket.
Yeah,
right, so that's what we suggested last time. Have a bind, so sort of a selector for bindable namespaces, and support it
that's
through,
what allows for the binding. The question is, though, then how do you do lifecycle management?
I think it's
right. So we try to assume that lifecycle is managed by the bucket and not by the bucket requests. So only in the greenfield case where the bucket request is the one that provisioned the bucket, it will be the owner.
Right, but how do you distinguish between a greenfield case with subsequent brownfield references and an all brownfield?
Right, you're going to have some sort of field on the bucket, the cluster scoped object, to reference the originating API.
No, so we suggested something else as well.
Guy, just real quick, John,
we suggested
your volume dropped kind of low compared to the other volumes. I don't know if something's going on at your end, just a FYI.
John, we also suggested that if there will be two ways of referring to it. So either the bucket will say, this is my owner, right? Once that bucket request is deleted, I want to be deleted as well, even if I have other bound requests and they will be sort of left unbound, become unbound or something.
Mm-hmm.
And the other option would be, I want to garbage collect this bucket. Basically, once it has no references, it should be deleted. And then it's mainly just a matter of reconciling bucket requests. Once they change, check if you still have references, and then decide to delete.
Yeah, I'm a lot more comfortable with the reference counted garbage collection approach than I am with the delete my original little requester and then we all go away.
But it's an owner sort of a thing, right? It always exists in every case when like an owner has a sort of saying to, I want my bucket to be deleted when I say so. So I don't know. It might be a problem not to have any way for owners to control.
But let's say an application may think he's going to become the owner, and he may be saying, I need a bucket called temporary logs, and I want that to be deleted after I'm gone. But what if that temporary logs bucket ends up being a brownfield bucket? So he gets provision access to an existing bucket, right? So I think it should be like a best effort to satisfy it. But even though if it was requested to be deleted after it's done, he may be actually thinking he's going to be a greenfield case, but he ends up being a brownfield case. So
brownfield case, you add a new bucket request to existing bucket. So the cozy controller should not set an owner in this case. It's pretty simple to detect. Right?
Yeah. So something consistent will be no owner, but the reference counting case makes sense in this case because it's like, okay, when the bucket requests are getting destroyed because they're no longer needed, and then we're evaluating whether we should be discarding the bucket or not, then maybe we can reach the state of say, okay, the bucket should be destroyed, attempt to destroy it, maybe the driver will reject it or the cloud service will reject it. It's fine. We did our best, but then next request comes into place and maybe the driver tells you this bucket does exist. So your greenfield attempt becomes a brownfield again, and then everything is consistent again, right? So bucket request, even though it's requesting something to a bucket that will be deleted, it's granted an existing bucket, access to an existing bucket.
So I don't think a greenfield request should be translated into a brownfield request ever. I mean, if you request request something that like a bucket that doesn't exist, so basically if you refer to a bucket class and not to a bucket, that's a greenfield request, and then the creation of the bucket in Kubernetes in the cluster scope will be will signal that that you created the bucket and are the owner, right, of the greenfield case. You wouldn't. I don't think you would translate it to this case to a brownfield if the bucket exists in the cloud service. That should go through. I don't know how we do that actually, but how do we import a bucket from user?
Maybe I was misunderstanding greenfields because then greenfields are more like ephemeral buckets, right? So if greenfields are ephemeral buckets, then
I don't think ephemeral, but an application managed bucket, right? It's managed just like a secret for the application or any other resource that the application is deploying and controlling the lifecycle. It's not necessarily even the application. So maybe the user, the operation manager of that application, deploying all the pieces needed for this application, would control the lifecycle of the bucket, be able to control when to delete it, for example.
I posited a scenario that maybe we don't have to support. I'd like to maybe bounce that idea. The way you just described it, I think, is exactly right, which is that if you know it's a greenfield case, you actually know that at maybe the time that you're doing your bucket request, and that you are asserting that you want ownership of this, and probably that you don't actually want others to have access to it. And that any time that you want to do a shared bucket, sharing beyond your workload, that is sort of by definition brownfield. Now, the only question is, how do you get a brownfield provision? I guess we could say it's always statically provisioned.
But think about it this way. What if you have the two clusters, one US West and one US East, and both you're trying to deploy the same workflow, and the same workflow says, I'm a greenfield request, right? But then underneath, you're using the same cloud provider. Let's say you're using AWS. So at the end of the day, you should be getting the same bucket, right? Wouldn't that be expected?
No, because on a greenfield request, you don't give the bucket name. You only give a prefix. It's assumed that it generates a dynamically unique bucket name, that you don't have a collision problem.
And your intention is not to bind to anything existing.
Okay,
right,
okay.
just if you were to, execute an S3, create bucket command and you type, bucket name foo, you're hoping not to get a bucket name foo. You're hoping to get, a new
Foo
bucket
1, 2,
called
3.
foo, and if it already exists, then you get an error.
Okay.
So this kind of ties back to the policy thing, which I want to get back to also, and that's that. So say we have this concept of an owner now for greenfield. If I'm creating my bucket, and we had considered Andrew, the model you had suggested, where I create my bucket and then I request access to that bucket. And kind of remembering now some of the things that kind of piqued my interest about that. One is, how do you identify that the request to access that bucket is coming from the owner namespace, right? Because I've defined my bucket request, it's created the bucket. The bucket access comes in now, and we don't have credentials yet associated with the bucket. So how do we know that those credentials should get ownership permissions within that bucket?
Right. When you say, well, why would the credentials have ownership permissions? That's an access.
Right. Well, the credentials they have some level of access within that bucket. If it's a greenfield bucket that I created,
right. So,
I expect to have full permissions in that bucket.
I'm suggesting the following, that if you can successfully create a bucket request to a bucket, then you can configure access to that bucket. So that's the first problem of whether or not you can even have access to that bucket, which includes whether or not you can do greenfield, whether or not you can do brownfield to an existing, that's a whole problem that we have to solve. But once you've got the bucket, the rest of this then is, that's why the notion of a local reference to a bucket is a good idea, because you've already passed that first local access control problem, which is, am I even allowed to get access to this bucket? If I am, then I just configure the specific access that I need, and that then gets implemented on the back end. Am I missing something?
No, I think maybe I'm missing something here. So is there an assumption then that, like, if I can access a bucket object, cluster scoped object in the cluster, I already have a user account in that cloud service that could access that bucket?
No. Okay. So this is why I was suggesting that there might be 3 layers to this. But so again, what I'm suggesting is, number 1, provisioning of the bucket is a problem of the provisioner and of local Kubernetes access control problems, right? We agree on that. So we can get a bucket created or we can share a bucket without actually being able to access it yet. But all that problem can be solved with whatever we decide for the fan-out mechanism. So then there is, okay, now this application wants to access this bucket that I have been able to map into my application space, so I know I'm allowed to access it. Now I've got to make that data path access work. That requires 2 things. It requires that I be mapped to a principal, and it requires that that principal be given access to that bucket. And so the principal being, and so you can imagine a scenario where you mint the principal and you mint the access as effectively one operation. That was basically the way we were looking at this before. Or you could look at it as minting principal is one path and minting access, assuming an existing principal, is another path. The advantage of that second mechanism is that it can leverage things like workload identity. So it doesn't actually require that you mint the principal as part of configuring the access. But if you scope the access piece down to, I already have a principal, then yes, you have a bucket, you have a principal, you're just minting access. So clearly, you would have to communicate both the principal and the bucket to the driver in order for it to be able to mint that access.
Okay. I think I see the piece that I was missing here. So the implication that I can see and connect to the cluster scoped bucket is proof enough that I should have access to that bucket to begin with. And then when I create my, my request for access,
that's the Kubernetes level policy decision, right? That's the thing that where we decide to allow something. Then you have to make that happen in the data path, which is what the whole driver is for.
Got you. Okay, that solves kind of a chicken and egg problem that I had in my head. That kind of goes into, well, if I don't have a user yet, how do I know that user should have access, et cetera, et cetera. So that makes that a lot clearer for me. And so then effectively, so when I create my bucket request, that's essentially just saying, yes, you do have access to this bucket. Here's the endpoint. Can't access it yet. You request access to that endpoint. Either credentials are minted or the service account is bound to the cloud service account. And now you have access to that bucket. Then the pod can mount this. I guess this is a wrapping bucket access API that would incorporate both of these.
Yeah, that's, okay. Yeah, I mean, I think that you end up having to have the same driver because it has to understand both bucket lifecycle and bucket access lifecycle and potentially IAM credential lifecycle. It has to have knowledge of all of them. So it makes sense to me that the flows have to be to some degree tied together through the driver. But again, like I said, the notion of workload identity solving one whole piece of that, or the equivalent, means that I only have to solve 2/3 of the problem in some cases. In other cases, I got to solve all 3/3.
Right. And then just to kind of complete the loop in my head here. So when I create my bucket credential request, I'm not just asking for credentials. I'm saying, hey, create it for either my bucket request or create it for that bucket.
And that's a logical line. I don't know what the physical line should be.
Right. Yeah. Maybe through API reference
because maybe it's always through a bucket request, and then the bucket request is the one that handles the fan out to the bucket. Right.
Risking sounding like a broken record, but that's why I say that a single object, a single resource could imply both things, right? So creating a single object that has everything you want in it, and then it virtually becomes either the credential request or the bucket request could be enough, right? Rather than having additional resources.
Daniel, I think the single request is basically where we started. And a couple of weeks ago, decided that we really wanted to separate access management from bucket management.
And in fact, I have a slide for that. So,
yeah.
Right. Yeah. So essentially, I create my bucket request. I get credentials all the time, whether it's greenfield or brownfield. But I think we've all moved past that at this point. And then lastly, so the bucket access API was another key thing that was when I was considering the model we're talking now, where I request access to a bucket, or rather request a binding to a bucket for my service account or credentials. It split the API between greenfield and brownfield at that point, because the bucket request in my head is essentially a endpoint representation, or rather a reference to an endpoint representation. The bucket in the cluster scope is the endpoint. So in the brownfield case, I don't really have a need for the bucket request then in my head. This is how I was thinking about it. So if my bucket credential is for access to a bucket, then I would just reference that bucket directly. It would make the bucket request kind of redundant. And then the way I saw it was that greenfield would be referencing bucket requests. Brownfield would be referencing bucket credential requests. You have this weird split in workflows that was jarring my mind.
Yeah, I mean, I absolutely think that, not that it's the right way, but it is a correct way to model this, as either you are talking about a request, which implies greenfield, or you're talking about a bucket, which implies brownfield. But that means you have to solve the access control problem for both the bucket request interface and the bucket access interface, which just felt weird to me, which is why I was thinking maybe you should always have a bucket request.
Yeah, I thought that's what we were going to try to solve, right? Because a question just popped into my mind. That means that if we have multiple bucket requests for a single pod, that means it wants 2 buckets, it will get 2 set of credentials, right? Which will imply that the application needs to be prepared for that. And I don't know how that will fly, because I guess that most application says I'm going to be getting one set of credentials to access 2 separate buckets. And I thought that we were exploring the part of, these credentials being provisioned to the pod, having the access to everything that the application was going to need, right? Or I was going in a separate direction.
Yeah, that's a good point. That's been on my mind too. So the use case is like, what if I'm in Google and I want to use, big analytics and GCS at the same time through one set of credentials? It's a single pod running a simple job. It's going to read from here and pipe it into another service in the cloud service. Like, how do we manage that? And then
I also have an idea. Oh, sorry, Jeff. Please go ahead.
Yeah, that is kind of why I was initially for not supporting IAM at all, because you start to see a lot of scope creep the moment you start to assume that a pod's going to do something other than just read.
Solves that problem.
Sorry?
Workload identity.
Yeah,
right?
yeah,
I mean,
workload
that's
identity.
exactly what that is.
Right.
Yeah, I'm feeling like right now we are looking at this problem like 2 pillars we have. Like, one pillar is provisioning credentials, and another pillar is provisioning bucket, and granting access to credential to bucket credentials access to bucket. We always trying to kind of stick it to one of the pillars, but doesn't it deserve its own pillar? And then for brownfield, for greenfield, we'll see how we can combine these.
Yeah,
but
that's
at least
exactly what I proposed in that doc that I sent out. I was thinking of them as 3 layers.
Right.
So this object then, so we call it like a I don't know, policy binding, can exist, and then sounding maybe redundant here, it can exist in IAM and the bucket side, but that's more of a black box test, like Andrew pointed out. Where should that API live, and who should be allowed to define it? And I ask that because if I'm creating a greenfield bucket and I want to be able to share it out, I should be able to define who I want to share it out to, who I should whitelist, right? If I'm creating but in a brownfield bucket, there's no owning namespace, which makes me think it should be a cluster scoped object defined by an administrator.
So if you imagine that you have buckets and you have bucket access. So buckets, there's clearly a case for sharing. It's an interesting question as to whether you actually want to share bucket access. There's only really one case that I can think of where that's legit, which is, oh shit, I've got to go too, sorry, but let me finish this thought. And that is the driverless case, where you don't have anybody that can support minting that kind of least privilege, revocable credentials for an application. But in the general case, you would want the access for that bucket, for that workload, to be uniquely associated with that workload. But if that workload itself has a binding to an existing application, to an existing service account, an existing IAM principle, you can still do that. In other words, managing your credentials is a different problem than managing the underlying access. So you could have a credentialing component that is just providing a binding between you and a principal. And it has nothing to do with buckets, honestly. It doesn't necessarily have to do with buckets. And then you can have something that specifically has a relationship with an equivalent but black box component in the cloud service, which represents the relationship between a principal and a bucket. And that you want to tackle as the first class problem. What I'm suggesting
that's IAM. That's making IAM first class. That's a big topic. We try to make the bucket a first class.
Just IAM as mapped to bucket. Yeah. I think you have to do that. If you don't do that, you haven't provided a mechanism to actually allow this to be implemented. I mean, you just don't have enough. The actual user part, the principal piece, you can support that with different variants of the access credential thing. So you could say, mint me access credentials, and oh, by the way, maybe the way this driver works, it just also mints a user and provides it. Maybe a different driver doesn't mint the user, expects there to be an existing user that you communicate to it, like an existing Kubernetes service account is passed in as part of the request. And then that's what informs it as to what it should be creating the IAM policy for. So I'm not sure it can be three completely distinct systems without fully taking on the IAM problem. But I think you can have two systems, and one of which solves both access and principal. Anyway, everybody's dropping off, so.
yeah. No, I think it's I think you make an important point, because the real world use cases for these is pretty much exactly what you said. I have to create my user, I have to create a bucket, I have to define my relationship to that bucket. And if we're not representing that here, then we're just creating this kind of murky mess of a relationship between the two. I'll go ahead. We got to drop off here, I'm sure. So thank you all for coming. We'll see y'all next week. I'll have the video posted to the working group here along with the slides, and we can continue conversation in that too.
Okay, guys.
All right.
Take care.
Appreciate
Thank
it.
you.